Okay, a true value of a proposition is true if the proposition is true, and is false if the proposition is false. Okay. So notation. Typically, we will use letter like P, Q, R, S to denote the proposition. And we will use a capital letter T to denote true, and F for false. Okay. Okay. So now in this world, you have a lot of propositions. So can you make new proposition out of these propositions? No. Who say no? Yes, you can. So you can. So this kind of proposition we call a compound proposition. Okay. It's like chemistry, right? You use different chemical, the elements in the periodic table, and then like H2O is formed by 2 hydrogen and 1 oxygen, right? So it's like compound. Okay, similarly to this proposition. So a compound proposition is a position formed from the existing propositions using some logical operators. Okay, such as the negation and or then and if and only if. Okay, so when you read in mathematics, you read the definition, or maybe in your coding, you need to be able to understand every word in the definition. Okay, so first of all, I'm defining compound proposition. Okay, so what's a compound proposition? Is a proposition. And then what I define for proposition is a proposition is a sentence that is true or false, but not both. And then what is sentence? Sentence is a complete statement. But I can't go back anymore because there must be a start, right? So I choose to start from a sentence here. Okay. Uh, yeah. And then also you should ask me what is the logical operators, which are these, and what are these. Okay, what are these? We are going to introduce now. Okay. So what's negation first? Definition. So let T be a proposition. Okay, so what's the negation of a proposition? The negation of a proposition not sometime, we always denote by this not P. Okay, is the statement it is not the case that P. Okay. Okay, so let's do some example. Let's copy these two statements. Okay, So it's done. E.g. So first example, let P to be this sentence. So what's not P? What's not P? Huh? It is not the case there. It is not the case that SM, Summer University is located in Japan. In the other words, you can say that Summer University is not located in Japan. Okay. Okay, how about the second example? What is not Q? What is not Q? Huh? Not every number. Then what is that? Okay, good. Not every number greater than 1 is less than a million. Okay, or you can repeat that it is not the case that every number uh, greater than 1 is less than a million. Okay, because this is by definition. Okay, it is not the case that something. Okay. Okay, another way to say is there exists a number greater than 1 is less than a million. And just now your classmate produced that number, which is counter example, which is 2 million. Okay, you found that number, which is 2 million. Okay, any question? Okay, so this every and there exists is something called the quantifier, which we will touch on again later. Yeah. Okay. Next. So okay, so what's the truth values of let's go back to notation first. So notation, sometimes we write not P like this. We also can write minus P. We also can write curly P. So if you see this in the literature, then you will know that this is not P. Definition. The truth. So since not P is a proposition, so we can ask about the truth value. Okay, truth value of a proposition. So true value of a negation of P is the opposite of the true value of P. Okay, so why is this true? So you should observe from here that if this if this is true, then this should be false. Right. So if Salmon University is located in Japan, then not P is false. Okay, and if this is false, and this should be true, which we already found this example, this number. Okay, so okay, from here we can draw a truth table. Okay, so what's a truth table? a truth table should include all the possibility of the true values of the proposition. Hello. Okay. Uh, I think this is the problem with the early class. Are you in the Moodle yet? Okay. Okay, so how is the truth tables looks like? So truth table will be looking like this. P, not P. So so every proposition you have how many true values? You have two, right? So what are the true value you can take? True or false? Okay. So not P. If P is true, not P is false. If P is false, not P is true. Okay, good. Yeah. Okay. Opposite. Okay, good. Okay, next. So in ordinary speech of writing, you use and or to connect sentences. Similarly in logic. Okay. Similarly in logic. So now we are going to define and. So let P and Q be propositions. So and we will call the conjunction. So the conjunction of P and Q, we will write it as P hat Q. Okay. So P and Q is the proposition P and Q. Okay. So when is this so conjunction is a proposition. So when is it true? So P hat Q is true when both P and Q are true. And it's false otherwise. So there's only one condition it can be true. Okay, let's see the truth table here. So Q, P hat Q. So you have true, 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 false, false, true, false, false. So typically you have like 2 times 2 possibility here. And then if you have more P, Q, R, S, and so on, you get times 2 factors from each of them. Okay, to count the total combination. Okay, so true P and true Q, P and Q is true. True P and Q false, P and Q false. False P, true Q, P and Q false. False P, false Q, P and Q false. Good. Very good. Okay, example. So P, let's say I have a durian, which is like P. Okay. And then I also have a vinegar. I say it's sweet. Okay, so what is P and Q? True or false? Huh? True? Who said true? Your vinegar is sweet. False. True or false? False. Why is it false? The vinegar is not sweet, so it's false. So this is false. Okay. Although the durian is spiky. Huh? So P and Q is false. Okay. Okay, next. Okay, let me copy this. Okay, next we will introduce an OR. OR. Okay, we will introduce OR. So OR here we call the disjunction. Okay. So disjunction of P, this is a different end. This is the English end. So denoted by inverted hat P or Q. Okay. And then the proposition is P or Q. So the disjunction P or Q is false when both of them are false and it's true otherwise. Okay. So it's kind of an opposite. Okay. So P true, Q true, P or Q is true. P true, Q false, P or Q is P false, Q true, P or Q. P false, Q false, P or Q. False. Good. Very good. So same example again. Same example here. Same example. So now the question changed. So hence P or Q is true or false? Huh? True. Why? Because P is true. Okay. As long as one of them is true, then P or Q is true. Okay. Okay. Next. So actually, you don't realize that there's two kinds of or in English. Okay. Okay, I'll show you the other kind of English. Or I mean. So where remark here. So the disjunction or we talk about just now is called the inclusive or. Okay. Because when both true, you also true. So this is the inclusive part. Okay. Now we'll define an or which is called the exclusive or. Okay. The exclusive or of P and Q denoted by P or plus Q. Okay. And we also call it P X or Q. Okay. X or. Okay. So when is it true? So this is a proposition. So you can ask about the truth value. So when is it? When is this exclusive or true? It is true when exactly one of them is true. Okay? You can only have one true. And false otherwise. Okay? Only can have one of them true, then your statement can be true. Let me see. Maybe I just throw it again. you have true, false, true, false. Okay, so true P and true Q, P XOR Q, you get false. Okay, right? It's only exactly one of them is true, and it's false otherwise. Okay, true P and false Q, false P and true Q, false P, false Q. Okay, then you might think, how is it useful in the real life? Okay, why is it useful? What do you think? Can you think of an example? Huh? Louder. Take order. Do you have more example? Oh, okay, very good. Okay, it's the same example I'm gonna give. Thank you. Yeah, very good. So it's like on the airplane, when the stewardess asks you for meal, you want uh, curry chicken or nasi lemak, then you only can pick one. Okay, you can pick both. Okay. Yeah, good, good example. Yep. Um, Also, for example, I will use all my bonuses to buy and maybe in real estate or buy a Tesla. Okay, so you only have such amount of money, but you can't buy both. Yeah. Okay. So I jot down the example from you. What's your name? Yeah. How do we call you? Like, how do we call you? Zoe. Okay. ZU. How to spell? ZHOE. Y. Okay. Okay. So example, choose a meal. Okay. Mm, okay. Maybe I write pick a meal between two. Okay. Yeah. Good. Very good. Next. Um. What time is it? Okay. Yeah. 8 more minutes. Um, okay. Next. Keep going. Please ask question if you are blur or confused, and slow me down if I'm going too fast. If not, I'm going faster and faster. The condition, the conditional statement, P implies Q, is the proposition. If P, then Q. Okay, if P happens, then Q happens. So since this is a proposition, we should be able to ask about the truth value. Okay. So when is it true? P implies Q is false. Okay. When P is true and Q is false. Okay. And true otherwise. So true things cannot imply a false thing. Okay. And let's draw the truth table again. Q, P implies Q. So you still have the true, 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 false, false, true, false, false. Okay, so true implies true. True or false? True. True implies false. False implies true. True. False implies false. True. Okay. So let us examine this truth table here closely. Okay. So if true implies true, this statement could be true. But true things cannot imply a false statement. Okay, so it's false. But false statement can imply anything. Okay, so false implies true is true. False implies false is also true. So false statement can imply anything. So there's no content about false statement. Okay. Okay. So give an example. Any question? Any questions? No? Okay. Give an example. So if it rains today, oh, this example I already gave 2 days. Only today rains. Okay. If it rains today, then University is located in Japan. So when is this true? Huh? When is this statement true? If it rains today, then Seng University is located in Japan. When is it true? What true? I'm asking when is it true? When can this proposition be true? If it rains today? What? Wait. So okay. So there's one answer. So if it rains today, then this statement is true. Then okay, let me write this is P. Then P is true. How about if it doesn't rain today? Is it true? Why? Who is saying? Who is saying? Who is saying? I heard someone. Can you say louder? Is it you? Who? Someone? You? Can you say louder? Yeah. Okay, false can imply anything. So even if it doesn't rain, this statement is still true. One is false can imply anything. The other one is we know that Xiamen University is always located in Sepang because this is always true. Okay, so you see, true. So this is true. Okay, even though it doesn't rank, you still will get the true. Okay, so there are 3 ways for this statement to be true. Okay, any question? Anyone blur? Anyone confused? Okay, we go really slow in this lecture. Later we will go faster. Okay, so again, next. So I claim if it rains today, then I will bring an umbrella. Okay, so question. When is this true? When is this true? When is this true? Huh? When is this true? Any idea? When is this true? Any idea? When is this statement true? Hmm? We have to finish this question before we have a break, okay? Say louder. When you bring an umbrella, then this statement is true, correct? So if you bring an umbrella, no matter it rains or not, this statement is true. Okay? There's one more possibility. Louder, louder. If it's not raining, okay, if it's not raining, then I don't care whether I bring or not. This statement is true. Yeah. Okay. Any idea? Any questions? Any question? Okay, this is one of the skill you need to master. You need to know whether when is the proposition true or false. This will be in the exam, okay? Okay, if not, we will have a break until 10 o'clock.
Can we reverse the table like this too?
Oh yeah, sure. Okay. Because you just put in all the combination. Recording of this class. Why?
It's too fast.
Too fast. Too fast I can go slower.
Then recording better.
Recording better. I'm not sure. Let me think. Maybe I can send to you.
Oh.
Yeah, maybe you email me.
Okay.
How should I give you? Then why you email me?
Thank you, sir.
Okay. Let's resume. So if you notice in the Moodle, I posted some lecture notes from previous years. There might be some content that I don't cover because I think they are just applied, which you can read on yourself. And maybe I won't emphasize much on those content. It's okay that you can read the extra section in the textbook for your own knowledge, because even for me doing the research, also I have to read something from different field. But so if I so I will upload my lecture notes after the lecture. So you will be tested based on my lecture notes. So I will give something that out of nowhere. Okay. It must be able to deduce from my lecture notes. And then regarding the recording policy, right? So for this semester, the university don't want us to like send the recording or publish the recording because they want the student to come back physically this year. So I might be able to put out the recording if all the students are back, or if you have special requests, then maybe I will send you. Yeah. Okay. Okay. Someone is complaining I'm going too fast. Okay. So please ask question. Don't feel shy to ask question. Just ask. Okay. Even though it's a stupid question, you just ask. Maybe it will help understanding, and also help the others. Who knows? Maybe others got the same question. Okay. Please ask. Please stop me. Okay. So if then, okay, come back to this if then business. So there are a few ways to say if then. So you need to take note. So first, if P, Q, okay, or Q if P. Okay. And also P implies Q. This is what I always mentioning. Because in mathematics, when we say if something, then we will want to have connection between these two. So we can go from P to Q. So P implies Q. Or you could say P only if Q. So or P is a sufficient condition for Q. So P is sufficient for Q to happen, but Q may happen itself or because of other reasons. P is just a sufficient condition. Or Q is a necessary condition for P. So that means if P happens, Q must happen. Okay, right? Because if P true, Q false, then the whole statement is false. Right? True implies false is false. Then this whole thing is false. Okay. So Q is a necessary condition for P. Okay. So next, Q provided that P happens, then Q happens. Or Q whenever P happens. Okay, these are a few useful different ways to say if then. Okay, next. Define three things here. So first of all is the converse. So a converse of a if then statement is the proposition Q implies P. So for this definition, what you need to observe here is I swap the place. I swap Q and P. Okay. If I replace this Q and P to R implies X, then the proposition will become X implies R. Okay. So the labeling is not important. What is important is the relative position change. Okay. So it's swap. Converse of P implies Q is the proposition Q implies P. So you swap. Okay. So this is the converse. Next is the contrapositive. Yeah, contrapositive. So this contrapositive is also very important. So the contrapositive of P implies Q is not Q implies P. Sorry, not Q implies not P. So you swap and then you negate both. Or you negate both and swap. It's the same. So these two are actually logically equivalent, which we will talk about it later. So if you want to prove P implies Q, you can prove not Q implies not P. So if you want to say P implies Q is true, you can say that not Q implies not P is also true. Okay, next we will talk about the inverse. Okay, so the inverse of P implies Q is the proposition not P implies not Q. So you just put not on both. Okay. Okay, I have some comment on why is it called inverse. Okay. Actually, you have some concept on inverse when you learn fraction. Okay. For example, 2. I want to talk about inverse here. Okay. Inverse. So 2 times half is what? Is 1. Okay. So half is actually called the inverse of 2. Okay. So let's see what happens if I have P implies Q. Okay. So I apply inverse to P implies Q. What do you get? What do you get? What's the definition? Go back to the definition. Inverse of P implies Q is not P implies not Q. Okay, good. Not P implies not Q. Right. So you apply inverse again. What do you get? P implies Q. So you go back to original one. Okay. So you go back to you return to the original proposition. Okay. Similar to this, because 1, if you multiply anything with 1, you get yourself. Okay. Okay. So this is the inverse. Why is it called inverse? Too fast. Can you get it? Now, please ask question if you don't get it. Just ask. Okay. Okay. Next. Okay. So next definition. Let P and Q be propositions by conditional statement P if and only if Q is the position P if and only if Q. Okay. So since this is a proposition, we can ask about the truth value. So what's the truth value? So this statement here is true when P and Q have the same truth values and is false otherwise. Okay. So example, what's the truth table here? P, Q, P is an Q. So true P if and only if true Q. So it's true or false? True, right? Because by definition, it's true when both of them have the same truth value. Okay. True P and false Q. What do you get? False. False P and true Q. What do you get? False. false P, false Q, true, because you have the same truth value. Okay, can follow? Okay. Hey, I forgot actually one thing. So, this attendance sheet, I will pass it down now. Please sign, and please don't help your friend to sign. Okay, ask your friend to email me. Okay, if he need to be absent or what, ask your friend to email me. Okay, so aside here, so we conclude that we have what negation and or XOR if then and if and only if if and only if are called the logical operators. Okay, these are operators. So operators are that means operators will take something and then input something and output something. So operators here takes in proposition and give you another proposition. Okay. Um, okay, and also these three of this we will call the connective. So they connect the sentences. Okay. Any question? No question? Yeah. Previous slide. Okay. Yeah.
Produce the same value.
What is the same values? What do you mean?
The table.
Truth table. Why are they the same?
Q by P
Yeah.
equal to P plus Q, right?
Actually, no. Like we can try. Yeah, we can try. Okay, let's see if I understand your question correctly. So, okay, let's try. I think this is a good question, right? So, since I already defined this new, wait, so this new proposition here, you should be able to ask about the truth value. Okay. Actually, I purposely don't work it out because you should be able to use previous definition to work out the truth values. Because already tell you what is implied, what is not. Okay, let's see. Okay, so your question is whether Q implies P look the same like this. Is it? Yes? Okay. So okay, let's check. Okay, let's check. So okay, we check the answer. So now is Q implies P. Okay. So okay, now is the testing of your knowledge. Okay. I define everything for you already. So Q implies P. True implies true. What do you get? False implies true. True implies false. False implies false. True. So they are different. So these two are not logically equivalent. So what I meant by logically equivalence is this. So okay, we still can do another exercise. So the next one is the contrapositive. Okay, next contrapositive. So we can do this exercise. So I pull the like not Q implies not P. Okay, not Q implies not P. This is the contrapositive. Okay, so I need to not first, right? So not, maybe I create a new row. I create a new row again for a second. So I create a new row. So not Q, not P. Okay, so not Q, I'll get false. So I'm looking at this row again, and then I not them. So not not false, not not P. false, false. So everyone follow how to get this? Okay, good. Okay, next. Now, then we do this exercise again. So false implies false. True implies false. False implies true. True implies true. So you see, these two has the same uh, truth table. Okay, so this one I teach you. Okay, these two have the same truth table, so they are equivalent. Okay, this is what I meant by equivalent. Okay, any question? No? Okay, we will come back to this again later. We'll come back to this again. But it's a good question. Okay, what else? Okay, logical operators. Okay, this done. Okay, done. Okay, so what can I ask? Like, what's the course of this? What you guys take is a software engineering, is it? Software engineering. Okay, so you have to do coding, is it? Okay, okay, good. So okay, now we will turn this language into the binary digit. So nowadays, the computer are built up by this binary digit. If you know about the 0, 1, so sometimes you see the videos like the 0, 1, 0, 1 keep coming up. So that's how they use it. So let's define what's a bit first. So a bit is a symbol with two possible values, namely 0 and 1. Okay, so we get the word bits from binary digit. So the start and the end bit. Okay, actually, in the frontier of research now, they are researching on qubit, which is the quantum bit. So if you heard about they want to build like quantum computer, so they're using quantum bit. So what is it about quantum bit? So in quantum bit, you can get 1, 0, 1 up to 9. So you can store more information at once. Okay. Now you can only display like 0, 1, 1, 0, 1. But in quantum bit, you have 0 up to 9. So probably faster. Okay. And okay, let's come back again. So usually the convention is we use 0 as false and 1 as true. Okay. So through this, we also can have not all and XOR so on. So for example, we can rewrite the truth table in terms of 0, 1. Okay. So P, Q, P, and Q. Let's say we got true, 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 false, false, true, false, false. So 1, 1, you get what? 1. P and Q, you get 1. 1, 0, 0. 0, 1, 0, 0, 0. Okay. Everyone follows? Okay. Next definition. So we can deal with a bit string. Okay. Bit string is a sequence of bits. So this sequence could be 0 or more bits. And the number of bits in the sequence we call the length. Number of bits. in the So for example, what's the length of this big string here? 1001. What's the length? Hmm? What is the length of 1001? Anyone know? Huh? Louder? 4. Okay, it's 4. Why? Because you got 1, 2, 3, 4. Okay, 4 bits. Understand? Or maybe we try one more. So let's see about this. 10000101. What's the length? Huh? 12? Yes. So this is a 12. 1, 2, 3, 4, 5, 6, 7, 8, 11. Okay. Okay, in the first class, there's someone asked me, how can be a sequence be a 0 bit? What's a 0 bit mean? What does it mean by 0 bits? So 0 bits, maybe we'll call it an empty string. Okay, it's an empty string. It's nothing. There's no 1 or 0. Okay, so empty string is not 0. Okay, 0 is a bit of length. What's the length? Huh? Louder, louder. Of length. Louder. Any answer? I hear something, but 0 is a bit of length. What? 1. Okay. So empty string is nothing. So if you put an empty string here, if you put empty string here, you still get back your original string. Okay. Right. So yeah. So the length doesn't increase. Make sense or not? Make sense? Huh? Doesn't make sense. Make sense? Yes. Okay. Yeah. Okay. 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 Next. Okay. Next. So we define the bitwise or. So let's do some calculation now. So now we do some simple calculation. Now we define this bitwise for n and xor. Okay. Okay, so you can only add 2 strings of the same length. Okay, you must make sure they have the same length before you add them together. And then how do you add them together? You add them bit by bit. Okay. So you add them at the corresponding bit. Right. So the reason why you want to add 2 same length is because, for example, if you want to add these 2 together, okay, where do you want to put? Do you want to put like this? Or you want to put like this? Or you want to put like this? Okay. But if they are on the same length, there's no ambiguity. We can do this. Okay. Okay, let's try. Let's try. Let's try. Let's try. Try some example. Okay, try find. Okay, find the following. So let's try 1 0 0 1 1 1 0 1 1 0 0 1 0 0. Okay, try this one. So let's try bitwise. Oh, so 0 0. What do you get? 0 1 1 1 1 0 1 0 0 1 0 1 1 0. Okay. How about bitwise n? Okay, let's try bitwise n. Bitwise n. Okay, put anyone miss out? Anyone don't know how to calculate? Please raise your hand again. Ask now, don't keep to the end. Okay, n 0 0 0 0. Okay, 1 1 1 0 1 0 0 1 0 1. Put one here. No one say 1 0 0. Okay, okay, right, that's right. Bitwise XOR. Okay, let's try this again. Okay, try XOR. So 0 0 0 1 1 1 0 1 0 0 1 0 1 1 0. Okay. Okay. Everyone following? Please ask now if you are not following. Okay. Okay. Next. Next. So next is the logic gate. I think you see logic gate in your physics before or somewhere else. So logic circuit receive input signal P1, P2. Okay, you can put as many as you can, finitely many. So it receive a bit and produce an output signal. Okay, the thing you need to know is what's the shape of this gate. Okay, let's see. So this is called inverter or a NOT gate. So if you input a P, what do you get? Guess. What's a NOT gate? Huh? What do you think? What do you get? What's the output? Huh? What do you get? No one there to guess. NOT gate, no. Huh? NOT P. Okay, good. NOT P. And then next I will introduce a OR gate. Okay. OR gate. OR gate. So you input P and Q, what do you get? Huh? Louder? P or Q? Okay. Next, you should guess what I want to introduce. So I guess it's a AND gate. So if you put P and Q, what do you get? P and Q. Okay. Yeah. Okay, and then we should come back to this Boolean stuff, Boolean algebra in the last chapter. Okay, what time is it? 10:30. Okay, next. Next, we will jump a bit into the next subtopic, which is logical equivalence. Okay, we want to see when are two things is the same. So in mathematics, we always interested in finding a pattern between objects and then try to see whether two things are equivalent or when are two things equivalent. So definition. So a tautology is a compound position. And tautology is a compound proposition that is always true. Okay. No matter what the true values of the propositional variables that occur in it. Okay. So, for example, it is tall or short. Okay. So a person is either tall or short. So if it's not tall, then it must be short. If it's not short, it must be tall. Okay. So no matter what, this sentence must be correct. It must be true. Okay. So we call this kind of proposition a tautology. Okay. Next, we define the opposite thing, which is called a contradiction. Okay. So you should be able to guess what is the definition right here. So a contradiction is a compound proposition that is always what? Opposite. False. Okay. For example, same example again, similar. It is tall and short. Okay. So a person can't be tall and short at the same time. So you contradict yourself. So this is a contradiction. Okay. 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 Exercise. Huh? Exercise. So exercise. So in general, you can show that P or not P is a tautology. And P and not P is a contradiction. Okay, so this is actually a general thing. P or not P is a tautology. P and not P is a contradiction. You want to do the exercise? Huh? Let me show the exercise. Yeah, yes or no? No? No. So you know how to do, is it? So use truth table to show by using. Anyone know how to show? Any idea? Let's see. Prove that P or not P is a topology. Okay. I think already half of you already sleep. So how to prove? Any idea? Louder, louder. Draw the truth table first. Okay. Okay, I follow you. You're a teacher. So I'll draw the truth table first. How to draw? Oh, first column is P. Okay, wait. Too fast. I cannot follow. Okay, first column is P. The second column is not P. P or not P. And then how to fill? Okay. True, false, false. True, false, false. And then next. Here got true, false, eh? You sure? Huh? Why got true, false here? Here is not P or. Huh? So say again. False, true. Okay, I change. I follow you, teacher. Wait. False, true, huh? Then why you repeat? Huh? Okay. I erase the redundant part. Okay, next part I do. What do I do? The column is true. Why? I don't know. True or false, I get true. Okay. False or true, I get true. So then, so the last column is always true. So by definition, P or not P is a tautology. Okay, very good. 100. Okay. I think you guys have to clap for him. Okay, very good. Okay. So you do this before or not? Oh, you do this before. Where you do it? Secondary school. Where is your secondary school? Ipoh. UEC or okay. Okay, very good. Wow, very advanced. So okay, good. Who can do the contradiction part? Anyone? Anyone want to try? Anyone else? Prove that he is a contradiction. Anyone want to try? Anyone's volunteer? The blue blue shirt guy. Yeah, you. Think you already start sleeping from the before 8 o'clock. So do you know how to do this? Yes? Okay, very good. No wonder you're sleeping. So teach me how to do. I time. Okay, how to do? I also draw column first. Tell me how to fill the column. Huh? P in the first column. Then not P. Then P or not P? N. Yes. Okay. Yes. P and not P. And then what do you feel? Huh? True. True where? Which one is true? P is true. And then not P is false. Okay. And then is what? It's true. True and false is true. False. Okay. Someone else corrected is false. And then is it enough? Yes. Okay, I give you 20 marks for answering me. Okay. So there's another possibility, right? P can be false as well. Okay. So not P is true. So P and not P is false. Okay. Since this is always false, since P and not P is always false, by definition. So by definition of contradiction, by definition, P and not P is a contradiction. Okay, so this is how you prove something is contradiction or not. So maybe sometimes it will get more complicated. Any question? I think the class is going too fast, too quiet. Quick, quick. Any questions? Um, any question? No, no, no. Some okay, some not okay. What time is it? Let's see. 7 more minutes. Yeah. So how? Okay. Now to try. So, so before we break, every row have to come up with a question. Okay, before next break. So I give you 2 minutes. Every row have to come up with a question for today's lecture. Okay, you can discuss with your friend at the back or you think one of yourself. After 2 minutes, I want one question from each row. You can come up with your example, you can come up with your question, anything. Or something you don't understand about this content today. Row. I mean column. You want column. One column. Right? 30 seconds, 30 seconds. Okay. Okay, 5, 4, 3, 2, 1. Okay. Hey, anyone haven't signed this tutorial attendance sheet? Attendance list? No? All done? Okay. Done? Done discussion? Okay. First question. The first row. Anyone? Any question? Huh? Quick. From the back also. One. Quick. If not, no break. Quick. Yep.
And all the explicit or is the thing. Not all the conditions.
So is the inclusive or uh tautology or not all, and is the exclusive or uh, or conjunction is the conjunction a contradiction? Is it? This is your question. Okay, maybe I turn this to distraction so that you got a pattern here. Okay. So this is the question from Caleb. Okay. Is the disjunction a tautology? Okay. I think this is a good question. Okay. These two are good questions. Okay. So, okay. Why is it good? So, first of all, if you want to ask something, is a tautology or not? Tautology has to be a proposition, but disjunction and conjunction are not proposition. Okay, they are logical operators that takes in proposition and give you a proposition. Okay, maybe you can change your question and say, is the disjunction of two proposition or is the conjunction of two propositions? Is the disjunction of two propositions a tautology? Is the conjunction of two propositions a contradiction? Okay, this is possible because disjunction of two propositions is another proposition. Conjunction of two propositions is another proposition. Then you can ask whether these propositions are tautology or conjunction, or contradiction. Do you get what I mean? Because tautology, both tautology and contradiction are a type of proposition, or they are proposition. Okay, their nature is a proposition. So you need to put two propositions together to say whether they're the same or not. Okay. So is this your question? Okay. Good. So I would say depends. Depends, right? Depends. So meaning what does it mean? So meaning I could have disjunction of two propositions which is not tautology and conjunction of two propositions which is not a contradiction. It is possible. It is possible that the disjunction of two proposition is a tautology, which I already gave you the example just now. I also can give you another example, which is not a tautology. Do you believe me or you want me to give an example? Huh? You believe me? You don't believe me. Okay, I think that is a good principle. Don't believe your teacher already. Okay, don't believe your teacher. So okay. So you want to test me, is it? Okay. Uh okay. Let me think. Let me think. Okay, I think the basic example is just the, or you want a non-trivial one. I mean the, I don't, okay. I mean just the original one is already not a tautology, right? See, okay. I transport it here again. So let's see this one. See? I don't need to know what is P or Q. This is very abstract. I don't need to know what is P or Q. And then I got the true, false thing, right? True, false, true, false, true, false. Okay. So what do you get? Just now you answer me, right? True or true? True. True or false? True. False or true? True. False or false? False. See? Not always true. This is a general disjunction includes general disjunction of two proposition is not tautology. Okay. Similarly, for this, use the exactly similar example. So I proved to you that P and not P is a contradiction. But in general, P, what's the general pattern here? So general pattern here is T F. So the general pattern here is true, false, false, false. Even worse. Oh, not even worse. I mean, you see? Okay. Okay, I think this question is really good. Okay, really good. Okay, you see, so the general pattern here is only one place that have a problem. Okay, usually it's this place have a problem. Usually this place has a problem because if everything is T, then it's a tautology, right? If everything is a F, it's a contradiction. But there's only a single place here that has a problem. Okay, so this is how far it is from away from tautology and away from contradiction. Okay, in general. Yeah. Okay, answer your question. Happy? Okay, next. This row. You got a question. Awesome.
Finish.
Oh, wait, okay. Wait. Only restrict to today's content. Okay, you want to what? It's that one. Turn that. Can you send me? How you send me? Okay, wait first. Any other question from here at the back? Any question at the back? No? You emailed me first. Okay, next row. Third row. Any question? No? Third row. Quick. Quick. That one. Yeah, ask. What is the application of chapter 1? Wow, very good. I think this is very important. Okay, so what's the importance of logic? So what's the importance of this? First of all, okay, let's come back to this question. So logic actually helps you to communicate better. Okay. So you understand when people tell you something, you should determine whether it is a proposition or not. Okay. So meaning you tell me this story, true or false, or you just believe. Or maybe the person didn't tell it properly. So you should ask back him. For example, this question. So Caleb asked me just now, is the disjunction a tautology? So this question valid or not? Sounds valid, but actually not. Tautology is a proposition. Disjunction is not a proposition. How can you equate these two together? Okay. So this applies to your everyday life. Sometimes the question actually doesn't valid. So you should ask back to that person again. Okay. Sometimes people are confused during daily conversation because actually they are asking non-question. The question doesn't even valid. Or they're confused about the question that is not a question actually. You get what I mean? Of course you're confused. It's not a proper question. Okay? So this is how think logically. So does this make you want to study logic more? Huh? You don't know. No. Okay, maybe. Yeah, this at least this is how I appreciate logic. Um, yeah. The room is so cold. Huh? Just turn it down. Why you don't say it just now? Just turn it up. Okay, I turn to 34 already. Okay. Why not ask at the first class? Any more questions from you? Huh? Why this class is too early? Okay. Yeah, yeah. Disjunction? Disjunction? You mean the real example? Which one? This one? This one? This one? What do you mean by give you an example of disjunction? You couldn't understand it clearly? Proposition? Yeah. Oh, okay. It's not about example. It's about definition. What is disjunction? So this, so okay, so very good. Okay, you ask this question. So, uh, so I have to go back to the definition. So when we say disjunction, so what is this word? So we always go back to the definition. So when is the first time I define disjunction? So I wrote disjunction here. So I highlight it here. Okay. But see, disjunction is following two proposition here. Okay. So you can't just talk about disjunction without these two things. Okay. So first, you see, I'm not simply writing this. Okay. So first, you need to start with two propositions to start with. Then you can talk about disjunction of these two. For example, okay, for example, who are you? I am. So you see, I can't say that I am a boy or who are you. I can't put these two together. You know why? Because who are you is not a proposition. Okay. So disjunction is an operator that it it's two proposition and I give you one proposition. Okay? Okay. 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 Next. No? Anyone from there? No question? Quick. No question? No. You understand everything? Ah. What time is it? 11 o'clock. Okay, yeah, so you already email me, is it? Maybe I put it into the tutorial time later. Okay, so we come back at 11:12 and then we will do the tutorial questions. Okay? Yeah, toilet break. Yeah. Huh? Which one? Which one? Okay, let me see. Why you don't ask now? Huh?
Too shy.
Too shy. Don't be shy. You should ask in the class. Because maybe I will go the same problem. It's not in the class. Then you find. Okay. So you're saying this different? I mean, why just not the same? So I say this inverse of this. Not inverse. Then I inverse this thing. And then I put it on the left side. So not discrete. Oh, yeah. Oh, okay. Okay. I'll ask in the class next time. Let me check. Where you sit?
Again, right.
Oh, yeah. At the back. Okay. Okay. Yeah. Okay. Understand?
Yeah.
Understand? Yeah. Okay. Understand?
Okay.
Can. Okay.
String language like 0 and 1, they are stored in 1 bits, right?
Yeah.
And actually, the null character is considered as no bit. The null character is slash 0.
Then say again.
The null character.
The northern.
The null character.
What's that?
Slash 0.
What's that?
Like,
Why just the oh, what? No. What's this? Where do you see that? Huh?
program.
In Burao?
Program.
Programming? Which programming is this? Oh, no, wait. Oh, okay. Actually, this 01, right, it's not the coding language, but it's the I think it's the computer how to process what you want.
And it's information language.
Yeah, I mean, this will maybe turn into the code like this. This one maybe just not every character has I think if I'm not wrong, every character has some representing big string. Yeah.
So actually, it's also considered as it's
I think so. Yeah. There's some big string that represent this. Every character.
certainly not considered 0.
I don't think so. So I think, yeah, maybe this is 0. Yeah, right, because it's button. So, so this is, I think this is what? 1 0. And then here is 1, yeah. And then this one should have a special. That's what I thought. That's what I thought. I think, yeah. Yeah, this two, yeah.
Which and binary is totally different.
Uh-huh.
Which and binary is totally
Okay. Okay.
So, for example, if I count bit, I count on the number of
Yes.
Yes. So it is more. So
Yes. 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 This thing is called the length.
length. Oh yeah.
Length of thing. Yeah, it's not the binary. Okay. Yeah. Okay. Email? Are you in the yeah, you see my but if you lost in the class, please ask in the class. Never mind, it's okay. Maybe others have the same problem with you. Yeah, don't be shy. Okay. Hey, Park, is it Park? What was the name? Let me check. His call. His call. So what you want to ask about, the answer is there. Just explain it. Just explain it. Okay. Ah. Mm. Wait. Okay. First of all, when you read this, do you understand or you don't understand? Mm. Okay, maybe I can explain. Okay, explain. Hello, testing 1 2. Okay. Yeah. So welcome back. So okay. So Pisco, yeah. So Pisco asked about this logic circuit here. So in class, I only thought about each individual piece here. We only think about this one, and this one, and this one. So what's this? Okay. Uh, okay. Good question. So I mean, you can input whatever value you want. But of course, when you build this thing, you are built for a reason. Okay. So in this case, you want to build something like this. Okay. At first, you look at this. How am I going to build a logic gate that gives this? Okay. The claim is this diagram here gives this logic gate. But in real life, there's not just one way to get it. Okay? So this is one of the way to get it. So what can you do? So what happened here? R go through the NOT gate. What do you get? NOT R. Q go through the NOT P and NOT Q go through N. Yeah. And then P and NOT Q go through all with this one you want. P and NOT Q or NOT R. Okay, so yeah, so this is what I mean by application. So sometimes I didn't cover this, sometimes I will cover it is too hard. But with what I taught you just now, you can just build this yourself. So why I say this is not unique, because you can put so many on here, on it back again, you still get that. Okay, so it's not unique. So um, yeah, so depend on what you want in real life. Maybe you want to be efficient, use the less gate to build. So you need to figure out what is the most efficient way to build the circuit. Okay. Everyone can see. Okay. Any more question? Also, the other class, someone asked this question. So, how to draw truth diagram for the DQ? Okay. So first of all, to talk about this, you need to tell me the bracket first. Which one to do first? Okay. I could do this Q and R first, or I can do P and Q first. Okay. There are two ways to do it. So you need to tell me which way first. Okay. But it turns out that any way you do it is the same. They are logically equivalent. So this is actually an algebra. This means S or XOR is associative. Okay, it's associative. Associative. So this means A times BC is equal to R and E. Okay. So actually, there is no ambiguity of talking about ABC. This is an algebra, and we will say more next week. Okay. Yeah, I already posted the tutorial question on the web on Moodle. So ideally should be we will spend like 15 or 20 minutes doing your own and then or discuss with your friend. And then we will talk again 11:20. And if that week have a quiz, then this time will become a quiz time. Okay. Yeah. So there's 3 more minutes. So you want to try first? Try first, and then we discuss the question together. So I will post the tutorial question 1 week, not 1 week before, but before the lecture, and you can try out yourself at home first. Maybe try it, not finish it is okay, but at least look at it so that you have some ideas. Okay, you can do yourself, and then we'll discuss soon. Or you can discuss with your friend, 6 of you, 3 of you, 2 of you. Yeah, there must be some. Actually, for the red shirt student, just now you asked me what's the importance of logic, right? When I first started studying mathematics, I also don't appreciate what's logic. I also think that it's tedious, boring. Seems like no connection to mathematics. But when you really want to ask some meaningful proposition, statement, theorem, conjecture, you can't ask it properly without logic. So you can't really communicate well if you don't have logic. Like I have a cousin studying foundation here. So he have an English class. So it seems that learning English. Actually, no. Actually, there's a lot of logic there. So maybe they ask the question, if there's a free course to take in the university, is it beneficial that to take a free language course? So how you understand, how you answer this question? So maybe the teacher complains some of the question is out of topic. So you are not in the logic of that question. Okay. So hopefully with this logic, we can communicate better and then use a better language, better sentence, better idea to communicate. Yeah. That's at least how I see it now. But yeah. Also, logic is the foundation of maths. So if something wrong with the logic, then the whole mathematical structure will collapse. Okay, let's start. Let's discuss the tutorial question. So, which are these propositions? What are the truth value of those that are propositions? So we start from maybe that row. So one by one. Yeah, one by one. Do not pass go. Is it a propositions? Yes. Why? It's a complete sentence and then huh? Complete sentence is it a true or false sentence? It's true. Why is it true? It's true. Why true? What is false? So it's not a proposition because this is a command, maybe true or false. And this is typically what you did in the military. So you just follow command. You can't ask is correct or wrong. You can't ask true or false because this is command. Okay. So in military, you just follow. Even though the sergeant asks you go to jump to the sea, you also have to jump. Okay. So this is a command. This is not true and false. Yeah. Next. What time is it? Next. Next. Yeah. Not proposition. Why? Not what? Doesn't that have true values? Oh, okay. So this is a question. So it's not a proposition. Okay, next. There are no black flies in my knee. True or false? I mean, proposition or not? Next. Yes. Okay. True or false? Why? The place will have a black fly. So you went there before? No. Cannot be no. Okay, it's okay. So false. So we maybe in this class we assume there are black flies everywhere. Unless you find my knee no black flies, then you can tell me. Okay. Next. 4 plus x equal to 5. Why? You don't know why. Okay. So it's not a proposition because it can be true or false. Depend on what x it is. Okay. So if x equal to 1, true or false? True, right? If x equal to 2, false. 4 plus 2 equals 6. Yeah. Okay. So because it can be true or false. Next. The moon is made of green cheese. Green cheese. True. Proposition or not? Yes. Okay. Why? It's not made of green cheese. How do you know? Okay, okay. So the moon maybe it's not made of green cheese, maybe it's white cheese then. Okay. I also don't know. Okay. Okay, false. Don't know what's the moon made of. Okay, next. 2n 2 to the power n greater or equal to 100. No. Why? Hmm? Why? Why is it not? Sorry? Oh, you don't know the n. You don't know what's the n. Yeah. So the n is not specified. So when is it true? For what n is true? Huh? For what n is true? Less than 8. 8. 8. What is 2 to the power 8? Huh? What is 2 to the power 8? Huh? No one can do the calculation. What's the 2 to the power 8? Huh? Okay, 256 is greater or equal to 100. Actually, 202 to the 7 is the first one. Okay. Okay. Uh, okay. Next, what is the negation of each of these propositions? Okay, we sort to this row here. Second row. Second column. So Janice has more Facebook friends than Yuan. Can you speak louder? Cannot hear from you. Janice doesn't have more Facebook friends than Yuan, or Janice has less than or equal friends than Yuan. Okay. Next, Quincy is smarter than Venkat. Okay, Quincy isn't smarter than Venkat. Next, Zelda. Huh? Zelda drives more miles to school than Paula. Okay. Next, Brianna sleeps longer than Gloria. Say again. Say again. Brianna. Okay. Gloria. Okay. So it is not the case that Brianna. Okay. So what others what others form you can say? Maybe Brianna does not sleep longer than Gloria, or Brianna sleep less than or equal to Gloria, or Gloria sleeps longer or equal than Brianna. Okay. Okay. Any question? No? Okay. We keep going. Keep going. Keep going. Okay. So next. So P, I bought a lottery ticket this week. Q, I won the $1 million jackpot. Okay, next. 10A. Not P. What is not P? Until which where? You? Yeah. What is not P? Huh? Okay, I didn't buy a lottery ticket this week. Next. Yeah. P or Q? B. Huh? But P or Q or B? P or Q? P or Q is what? P or Q? Hi. What's wrong? Say again, say again, say again. Say again. Well, you don't have textbook in your mouth, is it? What is P or Q? Hi. Uh-huh. No, it's not N. B is not N. So wait, help him, help him. Mhm.
not very taken in school. This way,
Uh-huh.
I'm all items for median for the check.
Okay. Oh yeah. Okay. Oh. So either I bought a lottery ticket this week or I won a million jackpot. Okay, next. Uh-huh. Okay, if you bought it this week, then you won it. Okay, next. Next. D.
I bought a lottery ticket and I won the million dollars.
Okay, you bought it and then you won it. Good. Lucky. Next. Hey, can you repeat again? Okay. Wait. Say again, say again. Say again, say again. Say again. If. Uh-huh. Part E or if and only if. Okay. Okay. Okay, good. Okay, next. Next. Not P implies not Q. Next. Jackpot. So if I didn't buy a lottery this week, ticket this week, I didn't want the $1 million jackpot. Next. Jackpot. Okay, I didn't buy it this week and then I didn't want $1 million jackpot this week. Very good. Next. 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 Are you sick actually? Are you sick or no? You can't see. Why you don't have your laptop with you, is it? So what's not P or P and Q? Mm-hmm. Mm-hmm. Can you speak louder again? Why? Can you speak louder? No, it's P and Q. It's not P and Q. P and Q, right? Huh? Why like life seems hard to you? Okay, right. Okay. So let me see. So either I didn't buy a lottery ticket this week, or else I bought a lottery ticket this week and I won the $1 million jackpot. Okay. Okay. Yeah. Okay, next. So determine whether each of these conditional statement is true or false. A, if 1 plus 1 equals 3, then unicorns exist. This rule. True or false? Why? For both proposition and false. So how do you know unicorn doesn't exist? No, because you haven't seen. Okay. So we assume unicorn doesn't exist in this class. Okay. So if 1 plus 1 equals 3, then dogs can fly. True or false? True. Why? Why? Both of them are false. Okay, dog can't fly, and then 1 plus 1 is 2. Okay, next. If 1 plus 1 equals 2, then dogs can fly. Why? Okay. What did I write? Dogs cannot fly. Okay, because 1 plus 1 equal to 2 and dog cannot fly. So true implies false is false. Next. True. Why? Okay. Okay, very good. Because 1 plus 2 equal to 3 is true, then we don't need even care about whether 2 plus 2 is equal to 4 or not. Okay. Next. Next, state the converse, contrapositive, inverse of the statement below. So if it snows tonight, then I will stay at home. What's the converse? Next. Who? From who? Okay. Yeah. So what's the converse? What's the converse? Okay, if I stay at home, it will snow tonight. If I stay at home, it will snow tonight. Next, contrapositive. Okay, if I do not stay at home, it wouldn't snow tonight. Next. Mm-hmm. Inverse. Okay, it doesn't snow tonight, then I wouldn't stay at home. Okay, next. I go to the beach whenever it is a sunny summer day. What's the converse? Oh, this is the same. This is the same, right? So you see, this is the if. This part is the if. If. Whenever is a if. Remember? So it's a Q if P. So the converse is uh, okay, can. It is a sunny summer day. It is a sunny summer day. Okay, just put SS day. SS day. Whenever I go to the beach. Whenever I go to the beach. Next. What's the contrapositive? Next. What's the contrapositive? Huh? Wait. B. Still B, right? If I go to the beach whenever it is a sunny summer day, what's the contrapositive? Huh? What's the contrapositive? And then this is the inverse. This is not the contrapositive. This is if this one. No, this one is nothing. Not none of the two. None of the is not contrapositive. Is not inverse. I want the contrapositive. Say again. I don't. If I don't go to the beach, then it is a sunny summer day. Yeah. So if I don't go to the beach, then it is not a sunny summer day. Okay. Next. So if it is not a sunny summer day, then I don't go to the beach. Then I didn't go to the beach. Okay. Next. When I stay up late, it is necessary that I sleep until noon. What's the converse? What? Converse or converse? Converse is what? P implies Q become Q implies P. Huh? Quick. Quick. Huh? Cannot. Okay. So P implies Q. So first of all, you need to determine what is P, what is Q. So P is this part. I stay up late, P, and then it is necessary that I sleep until noon is Q. Okay. So P implies Q. So the converse is Q implies P. So when I sleep until noon, it is necessary that I stay out late. Okay. How about the contrapositive? Not Q implies not P. So when I don't sleep until noon, it is necessary that I don't stay up late. Okay. And then what else? Inverse, not P implies not Q. So when I don't stay up late, it is necessary that I didn't sleep. I don't sleep until noon. Okay. Okay, quickly we go through the last four. So shout the answer for 48A. Anyone calculated already? Huh? Hello? Hi? Come? Yes, 11000. B 01101. C 11001. D 1101. Okay, so you need to calculate the bracket first and then do the rest. And then check your answer. Okay, and then these lecture notes and tutorial answer will be posted today, hopefully. Then you'll see it online. And then if you need recording or what, you email me. I'll send you the link. And any more question or not, please ask again or email me and I'll bring next week. And then see you next week. Yeah.
I have to go.
Yeah, you go.
Yes, I
Yeah,
know.
no, it's fine.